All right, everybody. I just pulled up to my inspection and just looking at the house from the road. It's a 1998 build, and it looks like it's got a stucco type product on it. And from where I'm sitting, it looks like it's probably EIFS, and it's in that EIFS time frame. So there should be some pretty good finds on this. Hopefully nothing too bad, but you never know. So EIFS, if it is EIFS, which I'll confirm, EIFS is an acronym for Exterior Insulated Finish System. It was popular back in the 90s, early 90s to late 90s. So we're in that time frame on this house, and it looks like EIFS from here. So we won't get into too much of a history lesson on EIFS, but there's essentially a bunch of different types, but there's two classes. So there's a PB EIFS and a PM EIFS, and this one is probably going to be a PB EIFS. So that's polymer based. Another name for that is a barrier EIFS. So what it is styrofoam boards, expanded polystyrene foam, and it's adhered to the wall with either glue or nails. Okay, and then you're going to put a stucco coat over it, like an eighth of an inch thick. It's going to have fiberglass mesh embedded into a base coat, then the stucco finish coat. So another term for it is synthetic stucco, which a lot of people refer to it as. The problem with it is the installation of it. So for years and years and years, people were installing it incorrectly, which was leading to water intrusion, major water damage, mold, all sorts of bad things. And it's all related to the installation. So it requires careful attention to detail and careful detailing to ensure that the cladding is tight. So the PB EIFS, the barrier EIFS, the idea of it was to be adhered to the wall, completely encapsulated and sealed to where no water can get in. And if it's not done correctly, well, water's gonna get in, and then we all know it's not gonna get out. So we're gonna go check for improper installation methods. I can almost guarantee you we find them, because they exist on just about every house that does have EIFS. But hopefully there's nothing too bad, but we'll point out everything that we see and kind of go from there. So let's go check everything out. So the first thing, if you look right here on the roof line, you got the EIFS touching the roof shingles. So you're supposed to have 2 inches of clearance from the EIFS and the shingles. That's to prevent moisture wicking. When water runs off the roof, it won't get sucked up by the styrofoam and cause water damage. We do have a piece of kickout flashing right there, which is awesome. That's going to help prevent water from getting behind that cladding as the roof water runs down the shingles and the wall. Okay, another thing we have is at the bottom of this cladding system, the fiberglass mesh that's put over the styrofoam board has to be completely wrapped around the bottom of that EIFS and then finished over. The fiberglass mesh needs to be embedded into the base coat, then finished over to where it encapsulates that whole wall and strengthens the system. This is a very common deficiency, but if you look, we have exposed fiberglass mesh everywhere. So that's not embedded into this base coat, which it should be. You shouldn't be able to see any of that, and then it should have this finish coat over the bottom of it. So what can happen there is when water runs off the roof, we don't have gutters, run down, it's gonna splash, it could wick moisture up from there. We got some impact damage in a couple areas. That's just from things hitting it. If you have impact damage on EIFS, you can have water intrusion. Our EPS bands on these columns are touching the concrete and the ground. We can't have that for moisture wicking purposes. So you have to have 2 inches of clearance from flat work, and I want to say 6 to 8 inches of clearance from finished grade. Got some impact damage there. That's not as big of a deal because it's just a trim band on a column, but still improper. We don't have expansion joints where our EIFS meets dissimilar materials, so it ideally should be stopped here with an end dam, and then we should have a bead of sealant there. So you want to use a low modulus silicone is the best, but something that's going to be able to expand and contract. We don't want control joints in EIFS. We do want expansion joints. So expansion joints should be at all your interfaces to prevent water intrusion. But other than that, There's not a lot of EIFS on this house, so, and most of it is covered. So the chances of water intrusion are not as likely, but with the improper installation methods that we found, mainly on this side, is going to be the side that's most susceptible to water intrusion. The biggest point of water intrusion would be here, and then from the bottom. All right, so I'm done. I'm going home, but I wanted to kind of recap everything. So we thought we were going to find deficiencies related to the installation, and we did, obviously. But an important thing to note is that this was not a invasive stucco or EIFS inspection where we're drilling holes, taking moisture readings, that sort of thing. This was just part of a home inspection. So during a home inspection, it's limited, so it's visual only. We're not going to do those sort of invasive things. So just because this system was installed improperly, we're not going to recommend that it be repaired unless we see significant signs of failure. And I didn't see any of that, okay? I just saw improper installation methods. So we're still going to tell you that. We're going to put a note in your report that says these things were not installed according to manufacturer instructions, according to the stucco or EIFS industry standards. And it can allow water intrusion, but that's all we're going to tell you. If it's not failing, it doesn't need to be fixed. And that's a mistake that a lot of newer inspectors make, and I made them when I was new as well. But anyway, if the system's performing, even if it's not installed correctly, you don't need to fix it. That's a waste of money. On the flip side of the home inspection, on the invasive stucco inspection or invasive EIFS inspections, what we would do is we would drill holes in the cladding and take a moisture reading with a pin of the substrate, so the wood that's beneath it. That's the only way to definitively tell if you've got problems, moisture intrusion, damage beneath the cladding system. I've drilled holes in some systems where you put your moisture meter in and it just goes straight through the wood. I mean, that's significant damage. So that's the only way to tell if you do have that. So it's worth every penny, you know, the $400, $500, whatever it would cost depending on how much stucco you have on your house, to find out if the system needs to be repaired, or if it has moisture problems that could cost, you know, tens of thousands of dollars to repair. It's worth that little small investment to find that out. But on the home inspection, obviously that's not something we're doing. But again, I didn't see any kind of signs of failure. If I were to drill on that house, I would have probably only drilled on that left side beneath that kick out flashing. So I'm confident that one, even though it's installed incorrectly, is probably okay, but only one way to find out.